Hello everyone, today we'll dive into one of the most cutting-edge and challenging topics in AI, recursive self-improvement, or RSI. With the release of Anthropic's latest report, a concept that once lived only in theory is moving toward reality at unprecedented speed. In this talk we'll comprehensively analyze RSI's current state, mechanisms, risks, and future, from theoretical foundations to empirical evidence. This talk is divided into 5 parts. First, we'll review RSI's theoretical origins and historical evolution. Next, we'll focus on the striking real-world progress revealed in Anthropic's report. Then we'll dive deep into its core mechanisms. After that, we'll discuss the huge risks and challenges that come with RSI. Finally, we'll introduce the technical and governance frameworks proposed to ensure safety. Before diving into the details, let's look at the core conclusions. Simply put, AI is accelerating its own development and much faster than we imagined. Anthropic's report confirms this. The core mechanism behind it is AI's automation of the R&D process. Of course, this brings huge risks, so building safety and governance frameworks is urgent. First, let's clarify what recursive self-improvement is. Simply put, it is AI upgrading itself. The core of this process is a positive feedback loop. The smarter it gets, the more capable it is of making itself smarter. Once this loop starts, it can lead to exponential growth in capability. It usually includes 4 key steps: self-analysis, improvement design, implementation/testing, and iteration. The idea of RSI didn't arise overnight. Its roots trace back to the era of Turing and Wiener. In 1965, mathematician I.J. Good formally proposed the intelligence explosion conjecture, a milestone in RSI theory. Werner Ving then popularized the singularity concept. In modern times, Yudkowsky, Nick Bostrom, and others have provided more systematic theoretical frameworks, particularly Bostrom's formula, which offers an important lens for understanding RSI's dynamics. Now we enter the most exciting part, real-world progress. Just this month, Anthropic released a blockbuster report, using solid internal data to prove that AI is tangibly accelerating its own development. This is no longer science fiction, it's technological reality. The report's core conclusion: AI is reshaping the R&D process, and this acceleration is exponential. Let's look at the concrete data. In software engineering, the change is striking. Since 2024, Anthropic engineers' code output has grown 8x. The share of AI-written code has shot up from nearly 0 to over 80%. AI code quality is now on par with human engineers, and in code review, AI catches 1/3 of the bugs that humans miss. On specific tasks, AI's efficiency has improved by multiple orders of magnitude. In research, AI's capability is also growing rapidly. The complexity of tasks AI can execute has leapt from 4-minute short tasks to over 16-hour-long tasks. Even more striking, the capability doubling time has shortened from 7 months to 4 months, meaning the acceleration itself is accelerating. In code optimization, its capability grew 17x in 11 months. Most critically, in 64% of cases, AI-suggested research paths are already superior to those of human experts. Let's summarize the evolution of AI's role. From initially being fully human-led, to chatbot assistance, to a coding agent that can write entire files. Now we are at stage 4, where AI has become an autonomous agent that can independently run code and delegate tasks. Stage 5, the closed loop where AI fully autonomously builds the next generation of AI, is no longer far off. So how is this acceleration achieved? The core mechanism is not AI directly modifying its own code, but through an automated outer loop for AI R&D. Simply put, AI is becoming a super assistant to human developers, taking over a great deal of tedious work like coding, debugging, experiments, and analysis. The human role shifts from concrete executor to higher-level supervisor and direction setter. This greatly boosts the efficiency of the entire R&D process. Of course, behind the opportunity lies huge risk. First is existential risk, the most fundamental concern. If a superintelligent system's goals are misaligned with ours, the consequences are unthinkable. Second is alignment drift. As AI continuously self-iterates, it may inadvertently deviate from the initial goals we set. A small deviation, amplified exponentially, can lead to catastrophic consequences. Beyond technical risk, we face governance and societal challenges. The speed of technology development has far outpaced the adaptability of our institutions and policies. This is governance lag. It may lead countries to lower safety standards in pursuit of competition. Meanwhile, the productivity explosion from RSI may aggravate social inequality and deal a huge shock to the labor market, causing many knowledge-based jobs to disappear. Facing these challenges, we are not helpless. At the technical level, there have been some active explorations. For example, the SAHOO framework published in March this year aims to monitor and control alignment issues in the RSI process by quantifying goal drift and enforcing safety constraints. The significance of this framework is that it attempts to transform the abstract concept of maintaining alignment into concrete, actionable technical metrics. Besides technology, governance matters equally. We need a global safety brake mechanism that can pause development when necessary. At the same time, we must strengthen international cooperation and transparency so all participants understand the risks. We also need to invest heavily in AI safety research to ensure the safety development pace can keep up with capability development. Ultimately, as AI takes on more execution work, the human role will shift to higher-level goal setting and ethical judgment. In summary, recursive self-improvement is already reality in progress, and the path to full autonomy is clear. For us, opportunity and challenge coexist. The most critical question is whether our social systems can keep up with the pace of technology. This requires all of us to work together to ensure AI's development ultimately serves humanity's common interest. As the report emphasizes, the question is not whether RSI will happen, but whether we can adapt fast enough. That concludes my presentation. Thank you for listening. We now move to the Q&A session. Your questions are welcome.